Yes. Yes. Today I would like to discuss about fiber optics. So what is the fiber optic? Optics means it is a form of energy. Optical fiber it is a thin cylindrical dielectric waveguide system. Optical fibers are using in the different fields, medical applications, industrial, communication, etc. So optical fibers are using different purposes like medical, medical in endoscopy. It is a main application, and communication from the moon and earth communication and industrial applications. So in generally, communication is transferred through carrier waves in any communication system. When the frequency of the carrier waves are high, then the information carrying capacity also enhances. As the propagation of light takes place in the form of high frequencies of waves, these light waves can be used to carry the information. For the proper guiding of the information carrying the light waves, the proper guiding medium, the material, that materials is called optical fiber. Optical fiber is a guiding medium or material which guides the information carrying light waves. To guide the light waves, optical fiber should be transparent to minimize the information and the information of the transmission losses through the optical fiber. It is a made thin cylindrical dielectric waveguide system. So the optical fibers are the waves are transferred from the one place to another place. It is a stepwise signal or parabolically towards the meridional rays. When the light rays traveling from one place to another place, it is a more than one mode of the signal. They cannot overlap with each other. The signals are passes from the one place to another place. It is a total internal reflection. So these are the wireless optical fiber internet system, the information and some of the contents of optical fiber. Introduction: optical fiber as a dielectric waveguide, total internal reflection, acceptance angle, acceptance cone and numerical aperture, types of optical fiber, step index and grad index fiber, optical fiber communication system, applications of optical fiber. So the introduction of optical fiber. The optical fiber is a long, thin, transparent dielectric material. And dielectric material means the valency band to conduction band nearer to 3 electron volts energy gap. The best example is PVC wires, ceramics, ebonite, mica, and transformer oil, which carries electromagnetic waves of visible and IR frequencies from one end to another end of the fiber, means is called total internal reflection. In total internal reflection is the light rays traveling from denser medium to rarer medium. The two refractive indices, the angle of incidence is greater than critical angle, that is called total internal reflection. In optical fiber, it is made up of glass or plastic materials are used as a dielectric materials. Optical fiber works as waveguides in optical television signals, digital data to transmit voice television signals, digital data to any desired distance from one end to another end of the fiber communication. The evolution of optical fiber in era of 1880s Alexander Graham Bell. And 1930s, the patents on tubing, and 1950s, patents for 2 layers glass waveguide system. In 1960s, lasers first used as a light source. The using laser is a ruby laser by Myman. And 1965, high loss of light discovered. 1970s, refining of manufacturing process. The total internal reflection was first demonstrated John Tyndall in 1870. In 1880s, the technology becomes backbone of long-distance telephone networks in numerical aperture. In numerical aperture is the total light gathering capacity of the power of an optical fiber of core cladding interface, that is called numerical aperture. So optical fibers, different type of connector and cables, as shown in the diagram. So the optical fibers, thin materials and flexible materials. The thin materials is as shown in the diagram, and flexible materials is, it is comparable to the thin material. Flexible materials is the losses is very high. The information carried by the light waves should need a guiding medium through which it can be transmitted safely. The guiding medium is called an optical fiber. Optical fiber, different type of connectors as shown in the diagram. So the structure of an optical fiber. So the structure of optical fiber, basically is a core medium, cladding medium, and protective jacket or buffer coating. The principle of optical fiber works on a total internal reflection. The light ray enters into the core, it propagates by the multiples of total internal reflection at core cladding interface is called the principle of total internal reflection of the optical fiber principle. These are the structure of an optical fiber. The linear cylinder is a glass core, and outer one is called cladding, and outer one is the plastic covering. The construction of optical fiber is basically 5 parts. One is called core, number 2 is cladding, number 3 is silicon coating and buffer jacket, number 4 is strength material, and outer one is outer jacket. These are the construction of optical fiber, different type of parts. The first one is core material. Core is the inner part of the optical fiber. It is a thin linear cylinder. It is made up of pure glass or plastic material. The thickness is around 50 mm. Its refractive index of core is 1.48, and it is denoted by N1. The refractive index of core is Ri of core is N1 is equal to 1.48. And cladding is, the cladding is a cylindrical part surrounding the core. It is also made up of glass or plastic like core, but with a less refractive index. The refractive index of core is greater than the refractive index of cladding. The refractive index of cladding is 1.46. 1.46. That means N1 greater than N2. The thickness of cladding is around 100 to 150 microns. It is denoted, the symbol is N2. And silicon coating is provided around cladding to improve transmission of light signal. The buffer jacket protect the optical fiber from the moisture. Strength material. In strength materials, it is optical fiber from the flexible fiber. The materials are manufacturing, it is a strength is all very high. Another one is the outer jacket. The total optical fiber is covered by black poly. Its poly materials are used the outer jacket. The outer jacket, the optical fiber core cladding materials are fabricated by glass or plastic fibers. The types of fibers is two different types. That is all glass fibers. All glass fibers means glass core with glass cladding fiber. All plastic fibers, plastic core with plastic cladding fiber. Another one is glass core with plastic cladding fiber, polymer clad silica fibers. These are the different type of fibers are manufactured, the manufacturing industries. The principle of optical fiber, it is a total internal reflection. Optical fiber works on the principle of total internal reflection. Once light ray enter into the core, it propagates by means of multiples of total internal reflection at core cladding interface. From the diagram, the optical fiber signal is entered into the core medium. It is a Jing-Jong method or a stepwise signal. It is a propagation to the inside the core cladding medium. So the refraction is the changing direction of light when it goes into material of different densities. So the total internal reflection, it is works on the principle is a refraction principle. So principle of total internal reflection. So from the diagram is air medium is N2, water medium is N1. So there is a critical angle and total internal reflection from the diagram. Let us consider any two media of refractive indices is N1 and N2 such that the refractive index of water medium is greater than air medium. That means core greater than cladding. Let light ray A traveling from the medium is N1 is incident at an angle is I. Let R is the angle of refraction in the medium N2. So if I is equal to theta C, then R is equal to 90 degrees is a perpendicular. And according to Snell's law is generally mu is equal sin I by sin R. Based on the principle, the refractive index is N1 one medium, N2 is another medium. The refractive index of water, refractive index of air. N1 sin I is equal to N2 sin R. I plus substitute theta C, N1 sin theta C is equal to N2 sin 90. Sin 90 is equal to 1 and sin theta C is equal to N2 by N1. Theta C is equal to sin inverse of N2 by N1, where theta C is a critical angle. So critical angle theta C is equal to sin inverse of N2 by N1. From the diagram, when the instant light rays less than critical angle, the light ray refracts into medium N2. When I is equal to theta C, the light rays travel along the boundaries of the two media, that is diagram 2. And when I greater than theta C, the light ray totally reflects back into the same medium N1. This phenomena is called total internal reflection. An extraordinary features of total internal reflection is that there will be no loss of energy during every reflection. Hence, the information is carried through longer distances through optical fiber with no losses. So what is the numerical aperture? The light gathering capacity of an optical fiber numerically it is equal to sine of the acceptance angle. That means NA is equal to numerical aperture. NA is equal sine of acceptance angle. Alpha M is acceptance angle, right? So from the diagram, here the signal is entering to the optical fiber signal. The signal is optical fiber is entering to the core cladding interface. This is the stepwise signal. From the diagram is, this is called the light is gathering of incident light ray. So this is called the acceptance angle is alpha M. When the light signal is transferred to the core cladding interface. So according to numerical aperture, the light gathering capacity of an optical fiber, or the numerical aperture, the final expression is NA is called NCO square minus NCL square whole power of, that is called numerical aperture. So according to Snell's law, N naught sin I is equal to N1 sin R. That means when the signal is entering to the optical fiber cable, so this is called optical fiber diagram. The signal is entering to the core cladding interface. This is alpha M acceptance angle. So this is called theta. This is called theta C. So theta is equal to 90 minus theta C. This is N1 medium. This is N0 medium. This is called N2 medium. N0 sin theta I is equal to N1 sin theta R. That is theta R plus theta is equal to 90. Then theta R is equal to 90 minus theta. That is N0 sin theta is equal to N1 sin 90 minus theta. That is sin I is equal to N1 cos theta by N0. N0 is the air medium. So substitute the values and finally get the value. Theta maximum is called acceptance angle is equal to sine inverse of N1 square minus N2 square, which is required as the expression for the maximum acceptance angle in optical fiber. That is called numerical aperture. And acceptance angle is rotating the acceptance angle about the fiber axis. Describe the acceptance cone of the fiber. Light launched at the fiber end within the acceptance cone along will be accepted and propagated to the other end of the optical fiber by total internal reflection. Numerical aperture is the light is gathering capacity of optical fiber is known as numerical aperture and is proportional to the acceptance angle. And proportional to the acceptance angle, NA is equal to sine of acceptance angle, and it is numerically equal to the sine of the minimum acceptance angle. So this is called numerical aperture. And numerical aperture is equal to NCO square minus NCL square whole power of. The types of optical fibers on the basis of variation of refractive index of core and cladding, the mainly due to the classified into two types, step index fiber and graded index fiber. So what is the step index fiber? The step index fiber is, in this optical fiber, the refractive index of core remains constant throughout the core and decreases from step N1 to N2 at the core cladding interface. My dear students, so from the diagram, the step index fiber, the propagation of the signal is the stepwise signal or Jing-Jang method. It is allows only single mode optical fibers only. One signal is allowed to pass through the core the following the diagram, the indicating the single mode step index fiber. Single mode step index fiber, it allows one mode of the propagation. One mode of the propagation. Step index fiber, it is classified into two types. Number one is single mode step index fiber and multi-mode step index fiber. In single mode step index fiber, the refractive index constant for core in this fiber. So the core diameter is around 8 to 10 mm and outer the cladding diameter is 60 to 70 mm. There is only one path of light ray propagation to the core cladding interface. This is called the single mode step index fiber. It is a refractive index of the fiber since light is transmitted from one end to another end of the fiber by the total internal reflection. These are extensively used because distortion and transmission losses are very loss. That is called single mode step index fiber. In single mode step index fiber, it uses the short distance application, and single mode step index fiber, the distortion loss or transmission loss or attenuation losses are very, very low because of it is one mode of the propagation. There is no any jump the signal. So the refractive index profile is as shown in the figure. So the core refractive index of the core diameter is 8 to 10 mm, and cladding refractive index is cladding diameter is 60 to 70 mm, and radial distance and optical fiber axis and core cladding diameters as shown in the diagram. And multi-mode step index fiber, the multi-mode step index fiber from the diagram, the signal allows more than one mode of signal. More than one mode of signal, the propagation, the distortion losses are very high and attenuation losses or transmission losses are high in compared to the single mode step index fiber. So my dear students, in multi-mode step index fiber, the construction of the fiber is small, similar to the single mode step index fiber, but dimensions of core and claddings are much longer to have more number of paths for light propagation. The core diameter is 50 to 200 mm, and cladding diameters are varying from the 100 to 250 mm. So it is also refractive fiber since light is a propagation in the multiples of total internal reflection. From the diagram, the signals are, it is allowed from the more than one mode of the signal, that is called multi-mode step index fiber. The multi-mode step index fiber, it uses long distance applications. Here the attenuation losses is high. The signal allow is more than one mode of the signals. Another one is graded index fiber. In graded index fiber, in this fiber, the refractive index of core continuously decreases from center of the surface. The refractive index maximum at the center of the core and minimum of the surface. This fiber can be single mode or multi-mode fibers. Graded index fiber is equal to the multi-mode fiber. The diameter of the core is varies from the 50 to 200 mm, and cladding is 100 to 250 mm. The signals are parabolically towards the midinal rays. The signal propagation more than one mode of signal, but the multiples of the total internal reflections. That is called graded index fiber. The difference between single mode and multi-mode fibers, my dear students, it is very important in your examination point of view. The single mode step index fiber supports only one mode of the light, and single mode fiber diffraction of refractive index of core cladding is less. The diameters of the core is 8 to 10 mm. No signal distortion and dispersions. The launching of light is difficult, and fabrication of the fiber is difficult. A numerical aperture is small, and light is used for laser. This is called single mode step index fiber. And multimode fiber is many modes are available for propagation of the light. The refractive index of core is large, diameter of core 50 to 200 mm. There is a signal distortion. Launching of light is easy. Fabrication of the fiber is easy. Numerical aperture is large. Usual light source is called LED. These are the basic differences between single mode and multimode step index fiber. And comparable to the step index fiber and grad index fiber, the step index fiber, the refractive index of core is uniform throughout the core and undergoes sudden step changes at the boundary of core cladding. The diameter of core is about 100 mm in case of multimode fiber and about the 10 mm in the case of single mode fiber. The light ray propagates through it in the form of midinal rays. The signal distortion is more, attenuation is more, and numerical aperture is more in step index fiber. In gradual index fiber, the refractive index of core varies rapidly. It is a parabolical manner throughout the optical fiber core cladding interface. The diameter of the core is about 50 mm in case of multimode fiber. The light rays propagate through it in the form of helical or parabolical towards the midinal rays. And signal distortion is very low, attenuation is less, and numerical aperture is less value. So this is called difference between step index fiber and grad index fiber.